Okay, in this part of our lesson, we're going to talk about how we can create that linear regression model, which is also called a line of best fit, from a scatter plot. So regression analysis is used to study the relationship between the variables x and y. We're going to see this by creating a linear equation called a linear regression model that fits the data. The goal for determining a regression is to obtain an equation from which to predict one variable based upon another variable. It's called the line of best fit. So this line of best fit is called a linear regression model. It's also the slope-intercept equation y equals mx plus b. So it is very familiar. It will allow us to make predictions by plugging in any x value to see the outcome. Based on our line of best fit equation, other data can be predicted, just like I was saying. There's two types of data. You can interpolate data or you can extrapolate data. So make sure you get these two terms written in your notes. So interpolate, that means inside. So the data points that you are given, you can see and make predictions because the data values are within the range of which you can actually see. Extrapolating data is looking outside that range. Again, you're definitely going to be using your regression model, and then you can make predictions. Now, note that the further away from the plotted values, the actual values that you are given, the less reliable the prediction. You're going into uncharted territory. So let's go over this again. Interpolate is inside the data values that you're actually given. Extrapolating is outside the data values that you're given. Here's our first example. Now we're going to use our multi-view calculator to get the data that we need. And what we're looking for is that linear regression equation. In other words, our linear equation written in slope-intercept form. Whenever we put our data values this time, it is bivariate data. So you're going to be putting in your x values into list 1 in the order that you see them, and then you're going to put in your y values for list 2. So x is going to be list 1, y is going to be list 2, and you need to make sure your order pairs are lined up. And this is going to take us to that 5-stat summary. Remember, it also gives us a lot more data, and we're going to be able to find the slope and the y-intercept of our equation just from the calculator. Now, once we get this, we will talk about interpolating and extrapolating again. So you can see our data points are plotted, and then we have this line. This is our line of best fit. It's also that linear regression equation or regression model. You'll see it said different ways. They are the same thing. So this line is going to be our y equals mx plus b. And if I asked, how would a student score if they studied for 3 hours, which is right here, we could go up and look to see and make a prediction about what they would make. This is interpolating the data. However, what if I went to 8 hours and I used the graph and went up here? I would be extrapolating. I'm looking outside the data points. So interpolating is using any of the data points, the range. So we have from 0 up to 6 hours. If we wanted to make a prediction outside of 6 hours, that would be called extrapolating the data. So let's look to see how you enter this into your multi-view calculator. Like I said, in list 1, so you went to data, just like when you're doing univariate. And in list 1, you're going to put in all your x values. And then in list 2, you're going to put the y values. And again, you're going to make sure your order pairs are lined up. Then you are going to go to second stat. And instead of picking one var stats, one variable stats, we are now doing 2 variable stats, bivariate data. Then you're going to make sure everything is highlighted. It should default that your X values are list 1, your Y values are list 2. If not, use your arrows to highlight correctly. And then you're going to click enter and you're going to calculate. And you can see that if you scrolled up where it originally started, you would get your 5-stat summary. But you're going to scroll down until you get to A and the B. Your A value right here. Your A value, this is your slope. So A equals, and we're going to just round to the 10th. This is your slope. This is the M part of Y equals MX plus B. This B, the B value, and we're going to round, I'm just going to round it to 65. This is the Y-intercept. This is the B value of Y equals MX plus B. So then we would just have our equation, Y equals 5.6 times X plus 65. And remember, X is hours of study and Y is our EOC score. So we can plug in and determine and make a prediction on, if I study for so many hours, about what score would I make on the EC according to this linear regression model. So let's make some predictions. Here's our equation, our linear regression model, and we're going to plug in hours. So we're just going to simply, if we study 2.5 hours, what would we make? So I'm just going to use my calculator. And 5.6 times 2.5 hours plus the original 65 gives me 79. So according to our linear regression model, if I study for 2.5 hours, I'm going to make about a 79 on my EOC test. Now, what if we just study for half an hour? 5.6 times 1/2 plus the 65 gives me 67.8. Now, what if I'm like, okay, I want to make a 100 on the EOC. How many hours should I study? So this time I'm going to replace Y, my outcome, with 100, and I am going to use my algebra skills to see what X is, which is hours. So we're going to subtract 65. We get 35 equals 5.6 times X, and now we will divide. And 35 divided by 5.6 gives me 6.25. So 6 1/4 hours is what I would need to study. Okay, what if I wanted to make a 91? Okay, let me erase this. Give us some room here. So this time, let's see how many hours I would have to study if I want to make a 91. That gives me 26, and then we're going to divide each side by 5.6. And that gives me about 4.6 hours. So you can see how you can use your linear regression model to either predict how many hours you should study or what grade you would make. So you need to know which one that you're trying to find, the independent or dependent variable.